write anything yet.
Wait.
But here's the concept. So I've got two A's and two B's to mess with, and I'm trying to find all the different combinations. So the way I'm going to do this to make sure I get everything down and to prove that I've done absolutely everything is I'm going to do this. So if I move to the left, I'm adding an A. And if I move to the right, I'm going to add a B. So if I do this, today's 13th all day.
Thank you.
13.
Now I got two A's. Now if I move to the right, I've got two B's. What happens if I start on A and move to the right? What do I have? Try again.
AB.
AB. And what happens if I move B to the left? AB as well, right? I add on an A. I already have two A's here. I can't add on another one because I've already used up two of them, right? So I'm going to move to the right. It's the only thing I can do. So what do I get? If I move to the right, what do I get? AAB. Which you'll notice is what happens when I move to the left here, right? The exact same thing. So I bet you can predict what's going to happen here. What do I get here? What do I get?
AB.
ABB. ABB. And then last but not least, I get this.
Vikings suck.
Double A, double B. And that's everything. Now, if I'm saying that AAB is the same thing as BAA, then I've gotten everything, right? So if this is the same forward and backwards, that counts. I've gotten everything written down. If it's not, then I need to make a little bit of an amendment. I need to write in that I've got BAA here. I've also got something else. Maybe not forward and backwards, but I've got ABA as possible answers, right? Same thing here with BAB and BBA, or BBA I should say. And then up here, I can also have BBAA, BABA, ABAB, and then BAAB and ABBA. So I've got lots of combinations up here, right? This top guy. But if I rule that as long as I have two A's and two B's, it's the same thing, then I've got it, right? So the reason I'm showing you this is because what I want you to do now with this concept and this way of solving it, for your warm-up, I want you to do this. 100 points to Gryffindor if you can name that shape.
This one?
Name that shape. Close.
A try.
Triangle is correct. What do they call it a triangle?
It's got three.
It's got three angles. That's right.
Three sides.
So here are the three angles. We're going to call them A, and we have three sides. Call them S. We have three A's and three S's. Here we have two A's and two B's. I want you to find all the combinations of three A's and three S's. Okay? We're going to rule that, for example, AAB is the same thing as BAA. So forward and backwards counts. Okay? So this would not be another solution, BAA, because it's just backwards, right? But we will count that ABA is different because it's not forward and backwards, right? It's a different ordering. Does that make sense? AAB is the same thing as BAA, so we're not counting that twice. But AAB is not the same thing as ABA. So here, ASA would be the same thing as ASA, right? Because it's forward and backwards the same thing. But AAS would not be the same thing as ASA, even though they contain the same parts. Are you small when I'm stepping? A little? Let me review it again. Over here, I would rule for this assignment, okay? We're going to say that AAB is the same thing as BAA, so we're not going to count it twice, okay? Because AAB is the same thing as BAA, just forward and backwards, right? I will say that AAB is different than ABA, though, because they're not just forward and backwards. Does that make sense? They contain the same letters, two A's and one B. but they're not the same forward and backwards, so we're going to count them as separate, okay? So I want you to list all the ways that you can organize 3 S's and 3 A's using this chart method. So what we're going to do is we're going to start at the bottom with an A and a B.
Wait, why B? What?
I'm sorry, not B, S.
Yeah.
My bad.
Okay.
So if we move to the right, we add S. If we move to the left, we add A. Find how many combinations there are. Go.
No.
Song of the day is Triangle. My bad, not good. Get it?
I don't understand. So what's the end goal?
I'll be there in a second. Find all the combinations.
There's infinity.
We don't need to talk about it.
There's infinity.
I'll be there.
The other ones will be on. I'm just saying.
All the combinations we can have create.
It's gonna.
So we can have 1 A, right? We can have 2 A. We can have 3 A. And that's moving to the left. We can have 1 S, 2 S, 3 A.
Right, because this is one open. Isn't that what that is?
So this is what we do.
No. Wait.
So I have A and B. I could have 2 A and B. I could have an A and B. I could have 2 B's. I could have an A and 2 B's. And we are that this right here.
So then this is a S. 1 over from here.
Forward backward, right? We're not going to count that.
Right?
We are going to count something like this and stuff. Does that make sense? Okay, same thing for here. So ASA, we would say the same thing as ASA, right?
No.
But AAS would be different than ASA, so we would count that. Does that make sense? This is a good way to organize it. That's why I did it. Try that out.
You're ready?
Are you ready?
You can turn it in now or on Friday.
Is that what you put?
Yeah, it doesn't matter to me. You guys need help on this?
I get
Because look, the original one, I'm going backwards.
Alright, so check this out.
It's fine.
Yeah,
So-
it's okay.
I have 2 A's and 2 B's, so I'm trying to find all the points to organize. So what I did, I started up with 1 A and 1 B. Right, that's one way to do it. It's single A. We're just
This is
if you want to think fighting game combinations, right? Single A, maybe a pun, B like projectile, right? Yes. So this is right.
right? Yeah.
So 2A is a combo, right? So
I'm
we
pretty
have
sure
a
I
combo
wrote
of double A. We have a combo of double
math. That's
We also have A and B together.
It's fine.
We also have double A and B. The way I organize this is so I can make sure I get everything down. So if I move to the left, I'm adding an A. If I move to the right, I'm adding
What
an A.
color
I have
is
to
yours?
be right?
color
A, B, A on your rule is separate than A, A, B.
I feel like
Because they're in a different order. But B, A, A, I'm not going to go separate because it's just A, A, B bad. Does that make sense? B, A, A. B, A, I'm not going to count because it's just A, A, B bad.
It goes after
Right,
that.
so
I didn't write it
same order
down.
back if you don't count it, but it's the same thing. Count it. So do that for 3 A, A, okay? That's not enough. There's way more than that. Find them all. And using this method is a good way to prove that you have gotten them all, right? It shows every possible combination. It calls it
Goes
tree.
that way.
yeah. Wait. That or I'm wrong. I think I'm. No, that's right.
Work together.
That's AAS, right?
Is it?
That's what I put.
Also,
And then these two merge into AAAS.
that.
Whoa, slow down. Was it AAS?
Yeah. Then they merge both of them.
Something like that. You did the A tree first. Yeah, it's combined,
That's
right?
combine the two colors.
I didn't use that one because it was never in the reading that what we
I'll play one more song for you.
Oh, are you guys reading?
That was Triangle by Bad Bad Not Good. They're jazz trio.
Okay, then what comes after?
3A.
Here's another song by Bad Bad Not Good called Time Moves Slow.
Bad, bad, not good. It's really, really bad. Really
So
not
then
good.
you put these up
They're
here.
bad and they're not good.
Put them up here?
Yeah. That's how that works.
Oh,
One of
okay.
the bands that are combining jazz and hip hop.
We both know that we're the best people on this. Oh, clearly.
Yeah.
I think we really have matched.
So how many A's, how many S's, 3 A's?
AAASSS is the solution. Right? We can use all 3 A's, all 3 S's. Don't three S's to mess with this time. It's not just A, and B, B. Otherwise it'd be the same thing we did, right? Just a different letter.
When do I end?
We are not.
Yeah!
He's so
That worked,
slick to
man.
come.
I don't know.
That's rad looking.
It's fine, you know.
Well, we have a max of 3 A's and a max of 3 S's. You see what I'm saying? With that
Dude.
line, we have right here 3 S's.
So now, what is it?
Just add one more. Wait.
No.
No.
Yeah.
No, we're just gonna call this good. I think we only got like half of them actually, because I think it branches up the whole time.
Probably. Then they just colorful.
She was like the big, she was a chihuahua, but she was like,
And the art teacher's daughter is not.
Yeah, I mean that's fair. You get like brutally yelled at in your house if it's not color coded.
I wouldn't be surprised if my mother did.
How dare you not color code this?
It looks bad.
I think mine is like the better quality.
Of course.
I mean, we should. Mine looks so neat. It's easy to understand.
Jackson Alex.
You know, it's like
My
that
vertical
stuff,
math
I can get that free 10%,
Oh my
guys.
god, yeah.
He said he's not gonna tune into live.
What?
Alex said he's not gonna.
What?
I said I'd go off. What's the week?
Ridiculous.
I'd go
Week
off.
of 13.
13th, half the day.
13.
16 and 17.
Alright,
No,
so
really?
Now, here's the deal. You're missing 3 S's, right? If you want to
There.
write 3 S's, go further to the right.
I think I'm only gonna fit 2 of these on a sheet. Like if it's that like small and just put it in there, I just draw how big it is. I don't know why. I just like not that.
Make sure you don't want to make sure all represented. So, for instance,
And then I'll
make sure that you write in this stuff too, right? ABA is another solution that comes with AAB. So make sure you include that, right? So your diagram isn't complete just by drawing all the things that I did, right? You also have to include stuff like that. Go back and look for those.
So,
Right. So see how my diagram in marker is complete? But it's not fully complete because I left out ABA, which is technically different than AAB, right? So make sure you go back through and find those as well and write them in.
The same thing over here.
yeah.
She's,
Wait, no, it's not.
but that's okay.
Alrighty, so
You made me, I wrote it.
that was bad, bad, not good with triangle and time move slow. Let's fill this out. Alright, so
So, there's that.
the first thing I'm gonna do is I'm just gonna keep moving to the left and get double A and triple A.
I just went back and forth and back and forth.
That works too. I'm also gonna get double S and triple S. Now if I move to the right here and the left here, I get the same answer. What do I get? AS. As. So notice I've already covered my single letter options, right? A and S. I've covered all my 2-letter options. AS, double A, double S. Now it's time to go get my 3-letter options. I already got some. So I can't move to the left anymore. I gotta move to the right. When I do that, what do I get? When I move to the right, what do I get? A, and then I add an S, right? Moving to the right adds an S. If I move to the right here, I add an S. What do I get? And now everybody's paying attention. If I move to the left here, notice I get double AS, right? Same thing here. I get ASS. Do I have all my triple letters here? Sort of. What else do I need to add in?
Wait, so if you add in there.
Wait, we have to do all that.
What else do I need to add in?
Wait.
There's only one way to write 3 A's, right? Is there more than one way to write 2 A's and an S? Yes, there is, right? I could do ASA. Is there another way? SAA would just be this backwards, right? So that's it. There's only one way to do it. One other way. What about this one? What's another way I could write this? SAS. Cool. Only one way to write triple S, only one way to write triple A. Alright, so now I'm going to move to the right, because again, that's all I can do here. If I move to the right, I'm adding an S. So I've got A. I'm going to write it like this, and I'll show you why in a second.
Yeah, I think we actually seriously. We can't do
Oh, the other one's the
S.
oh, what is it?
Right?
S.
If I move to the right here,
So we didn't really get it.
what do I get? I add an S, what do I get? AASS, right? Feels like there should be an N in there. And S. Alright. Did you know that they have anise cookies? Do you know what that is? Anise? It's spelled like this. It's a flavoring. It's what makes licorice taste like licorice. So when you buy these at the store, they're usually around Christmas time. They're like Santa cookies is what they're called. They're anise cookies. Yes. I don't like them. I think they have a terrible flavor.
It tastes like
I think I really like them.
Double A. If I move to the right, I get another S. And I'm going to write it like this. Adding 1A gets me there. I'm running out of room. Here's what I'm going to do. Oops, I'm not going to do that. That's not going to work.
So basically, you just
Let's do
skip
this.
that row.
More like a million.
Right? Did we just skip one?
Yeah, we skipped one.
Can we skip one? What are we missing?
No,
as
me and
in
Landry
we
skipped that
did.
entire row.
Oh, you skipped that entire row.
Yeah,
Yep.
we did, me too.
Shame on you. Alright, what else am I missing
Oh well.
from this row? What else can I write? Is there another way to organize this?
Yours might be more effective.
I can do ASAA,
That's it backwards, isn't
but that's backwards.
it? Yeah.
Double ASA, so that doesn't count. Is there another way to write double ASA? ASSA, only one S.
ASA. No. Never mind.
What's another way to write this? That isn't the same, forward and backwards.
AAAS.
Triple AS.
Yeah.
Is that everyone? Everyone? Every way to do it? Sorry guys, I got a headache today. Not on my A game.
It's backwards.
Any other way to write that? Well, think about it. The S is the thing that's going to move, right? So if we move it here, it's A, S, double A, which is just that backwards. If we move it again, we have S, triple A, which is the same as that. Same thing here if we move it over. Triple A, S. That's it. How about this one? Other ways to write it. How about ASA, S? That also gets us SASA. What's another way to write it?
Class try to pronounce these.
David, what's another way to write this?
SSAA.
SSA is just that backwards. We're not counting that as separate.
Is that the only two ways?
Nice. So starting and ending with A. What's another one, David?
David.
Good job, David.
Thank you.
All right, David, you're going to keep going. This one. Write it another way. First of all, David, how many ways would you expect to be able to write this?
A lot. 4.
Somebody answered.
4.
How many ways would you expect to be able to write? And why?
4 places.
Don't tell me, well, I did it and I found there was this many. Tell me why you would expect the number. Yeah.
4 because there's 4 numbers.
2.
Why would you expect 2?
Because the other one had the exact same.
So check it out. These are the exact same thing. It's just the A's and S's are switched. So if there's 2 ways to write this, there should be 2 ways to write that. David, what's the other way to write SASS? David?
SSSA.
Good. I'm going to write it ASSS, which is the plural, obviously. All right. Cool. My tree is not done because I've not used all my A's and all my S's. I still got plenty of room to go. So I'm going to go to the right, which should be, according to my chart, the same as this going to the left. What am I going to get?
So actually, we skipped 2 rows.
Oh no.
So I'm adding on an S. What do I get?
Oh, This is just a word.
That would be F for me.
All right. Checks out. I rearranged them just a little bit. I felt it made a little more sense here. I'm kind of using the triangle,
Someone needs to say that one.
how A's and S's alternate. I'm kind of using it. What about here? What's going to go here? 2 A's and 3 S's, right? I'm going to write it like this. Danny, give me another way to write ASASA.
SASAA.
At least we got a half right.
Give me another way, Danny.
Almost down.
AASAS.
AASAS, that's that backwards, sorry.
AASSA.
AASSA, okay, that's different.
AASSA.
Give me another one.
There's no E's here. AAASS.
Is that all?
I believe so.
Can anybody find any more?
SS. Oh, I guess not.
So starting with 2 S's is out, starting with 2 A's is out, starting with 3 A's is out, starting with 1 S is out. Have we started with 1 A yet?
Yeah.
We have, just this one backwards, right? Okay. 1 S, 2 S, 3 S. 3 A's, 2 A's, 1 A. Seems like we've done all the combinations. Let's try this one. How many combinations would you expect on this
2
one?
of the rows.
You missed one on
Did we? What did we miss?
the AASAS.
AASAS, already got it.
Oh, you did?
Just backwards. Yep, down here. Sorry, it's down here. Yeah.
S A A A S.
SAAAS. We missed one. Starting and ending with S with 3 A's in the middle.
You just skimmed the 1 letter row. We missed exactly half.
Any others? We've got 2 S's in the middle. We could have 2 S's over here, but it just flopped, right? Reverse. So that's counted. We have 3 A's on the left, we've got 3 A's in the middle, 3 A's on the right would just be this backwards. Any others? I think that's it. How many would you expect over here then?
The same amount. I don't know.
The same amount, right? Because we have 3 A's and 2 S's here, we have 3 S's and 2 A's. It's going to be the same combination. So let's cheat and go over here and just write, instead of the S's, we'll write A's. Instead of the A's, we'll write S's. So I'm going to write A, and instead of the A's, I'm going to write S's. And that's going to get me all my combos, right? I've got S, S, S in AA. And I've got S and S with 3, whoops, sorry. I've got A and A. Ah! What am I doing here? My colors and letters get mixed up. I've got A and A, and then S, S, S. Scribble these out. All right, moving on. I should have one thing left according to my tree diagram, because it all converges at the top. So going to the left from here and going to the right from here should get me the same thing. What's it going to get me?
Really close. A, S, S, S.
3 A's, 3 S's. I'm going to write it like this, and I'll show you in a second why. How many different ways are there to write that? We can do triple S and triple A. What else can we do? How about we start with double A? Single S, single A, double S. You got a lot, right? I'm going to stop there. Why are we doing this, other than just for a warm-up? Well, it turns out these are all the different things you can check on a triangle in each order, right? So you can check an angle, and you can check a side. You can check an angle and an angle. You can check an angle and a side. You can check 2 sides. You can check 3 sides. You can check 3 angles. You can check 2 angles, then a side, then an angle, right? And the reason we're doing this is to show you how many different combinations there are. There's a lot. So today we're going to be proving triangles congruent, looking at 2 different triangles and trying to prove that they're congruent. And for triangles to be congruent, it's a little more complex than proving segments congruent. For a segment to be congruent to another segment, what has to be true?
Their length.
Their length has to be the same.
Yeah.
That's the only thing a segment has is length. That's all it's got going for it. Like some of you guys, right? You don't have much going for you, right? Like Danny. All he has is not his length. So he's more like an angle, right? For 2 angles to be congruent, what do they have to have the same?
The angle.
Their angle, their measure, right? Their measure, the measure of the angle, right? That's all they have is their measurement. Triangles are a little more complex, right? Danny might be an angle or a segment, right? Who in here has a lot going for him? Landry's got a lot going for her, okay? She's got a lot going for her. She's got art going on, she's good at math, all kinds of stuff. Everybody look at Ellie. Her hair's really nice, she's got the little band thing going on, she's got a lot going on today. She is a triangle, okay? So, Danny, very simple, one thing to check. Are they congruent? Are they the same size?
Yes.
Yes, then they're the same person, right? Ellie's more complex than Danny. She's got a lot more going on. She's got personality, right? Danny, all he has is height. So, checking all of these things could be a pain in the butt, right? For a triangle to be congruent to another triangle, all of the angles have to match. And all of the sides have to match. So we have to check every single side, and we have to check every single angle to see if they match, right? That is awful. So my question today is, what's the minimum number of things we can check on 2 triangles to make sure they actually are congruent? Do we have to check literally every single angle and every single side every single time? No, that would be a pain. Turns out we don't need much, and I'll prove it to you. So, first of all, if I just check one side on a triangle, here's one side. Here's 2 triangles that have the same side. How many different triangles can I make with that one same side? We are apparently on a hill, guys. All right. Well, here's a triangle I can make that has this side length. Focus on the yellow. That's the thing that's going to be the same. But can I also make a triangle with that yellow side length that looks like this? This is called proof by contradiction. I have proven that with just using this length right here, that's not enough to prove two triangles congruent, right? If I give you two mystery triangles and I tell them they share the same bottom length, that doesn't mean they're the same triangle, right? Triangle A could look like this with that bottom length, and triangle B could look like this with that bottom length. They have the same bottom length, right? They share the same side, but they're different triangles. So it's not enough to prove they're congruent. So it turns out just knowing one side for both triangles isn't enough to prove they're congruent. I could have this triangle
So two sides, right?
and this triangle, right? Both have the same side on the bottom, but they're different triangles. So it's not enough to prove it. What about two sides, right? If I've got two sides that are the same. So here's two triangles with two sides that are the same. Doesn't matter what angles, right? We're just talking about sides right now. Is that enough to prove that these triangles will be the same? If I tell you these two match up,
No.
why not? Well, we can demonstrate pretty easily, right? There's one way to make that triangle. But using the same two lengths, right, we can make another triangle. So it's not enough to prove that they're congruent, right? So
You do have
one
to.
side is not enough, two sides is not enough. What if I knew all three sides? If I knew all three sides, remember, all the sides and the angles have to be the same, right? So if I know three sides are the same, okay, I don't know anything about angles, right? I don't know anything about angles. Is that enough to prove that these two triangles will be the same? Obviously, they're not triangles yet.
Maybe. I don't know.
Well, let's see.
Yeah, because you can't add another side to triangles.
Is there another way to connect these using these three side lengths than what I did? No, because if I try to change the angle, look what happens. It becomes not a triangle. So when we know the three sides, it kind of locks in the angles, doesn't it? Right? Same thing here, and I'll prove it. Even if we have longer sides, like all the sides aren't exactly the same, right? If I know I have to deal with side lengths like this, there's only one way to make this triangle. Right? Still not a triangle, still not a triangle, still not a triangle. Now it is, and that's the only way to make it. So three sides is enough to prove that the triangles are the same. It locks in the angles, right? So all the angles will be the same. Right? And by all the angles, just so we're clear, I don't mean that all the angles equal each other. I mean that the corresponding angles equal each other. Remember we talked about corresponding angles with transversals and stuff? Turns out corresponding angles are more than just transversals. Corresponding angles are angles that are in the same relative location, right? Remember that from last semester? Angles that are in the same relative location, cap corresponding angles, right? These are in the same relative spot. So they're congruent. These are in the same relative spot, so they're congruent. Are these two angles congruent? No. This angle here is smaller than this angle. But the relative spot ones are. So these side lengths kind of lock in what angles we have. And so it makes these triangles congruent, right? The angles check out, the sides match up. So these two triangles are congruent. Are you smelling what I'm stepping in a little bit here? Now a harder thing to check is angles, right? Because angles don't have length. So notice before when I was doing this, when I gave you two lengths, I capped them off, with these two dots, right? To show you that those are the lengths I'm talking about. They couldn't be bigger. So when I don't have a dot here, I'm not telling you that the length has to be this size. It could be bigger. I'm just setting an angle. Does that make sense? I could add on more here. It wouldn't change the angle. Or at least it wouldn't if the magnets had pulled. Right? Same angle. Right? Still the same angle, just different size. So if I have a dot on the end here, that means I mean that length specifically. Right? That length is locked in, that side is locked in. If I don't have a dot, it means the side isn't locked in. You following me? It can be different lengths. So, let's check one angle. Here's one angle. I'm not specific about the sides, okay? So here's two triangles that have the same angle. And I know they're the same angle because I'm pushing them together as much as possible. That's as much as I can push them in. There's no more room to push them in. So I know these angles are the same. So if these have the same angle, do I know that they're the same triangle? Why not, Luke?
Well, because both ends don't have to be the same length.
Check it out. What if I extend these lengths, which I'm allowed to do, right? All I said was the angles had to be the same. If I extend these lengths out, these two triangles have the same angle? They do. Are they the same triangle? No. So a single angle is not enough. What about two angles?
Yes.
What about three angles? Here's what I want you to do. Get out a piece of paper, preferably graph paper, go to the back, and you're going to prove, you're going to check all these things, okay? We're going to try the minimum number. And the reason we did the chart like this, so before you jump up, the reason we did the chart like this is because if I know that 3 sides is enough to prove it, then I know that's enough to prove it because it has 3 sides in it. I also know this is enough to prove it because it has 3 sides in it. And I know this, of course, is enough because it has everything, right? So start from the bottom and work your way up. Let me say it again. If I know that 3 sides is enough to prove a triangle congruent to another, then I know that 3 sides and an angle is enough, right? Because now I have even more information. So if we get this, everything that's touching it above, we get for free. I'll say it again. If I know 3 sides is enough, then I know 3 sides and an angle would be enough, right? If I gave you all that information plus an angle, of course that'd be enough to prove, right? Same thing if I gave you all 3 sides and 2 more angles, right? Anything above this on the chart would tell me that, yeah, that's enough information to get it done. We want to find the smallest amount of information needed to get it done. That way we don't have to check all this stuff, right? So 3 sides is the minimum we found. What other minimums can we find? How I would check this on a paper if you're not using these guys would be this. So let's check 2 angles now. I'm going to get out my protractor. I'm going to draw 2 lines. So I'm going to draw a line like this. What angle do you want me to give it? What angle do you want me to measure?
40.
40, okay. So what I do is I take this line on my protractor, see that line right there, and that dot? I put the dot on the end and line up that line with my purple line. I find 40 on here, and I put a dot, and now I'm going to draw an angle that's 40 degrees. I'm just checking angles here, so size doesn't matter. So I'm just going to do this, and that's a 40-degree angle. Now I'm going to draw another triangle with the same angle but different lengths, right? Because all I'm checking is 2 angles, right?
Size doesn't matter.
Size doesn't matter. You're in luck, Danny.
I know, pretty big.
So that's 40, and that's 40. What other angle do you want me to make? Because we're checking 2 angles. We're checking double A. 80. All right, so I'm going to go here. I'm going to make an 80-degree angle. Here's 80. Now you'll notice in order to make an 80, I have to go like this, and it doesn't quite connect. But that's okay. We're not checking side lengths. So I'm going to draw this line right here. And I'm just going to continue this one out. Because remember, length doesn't matter. Danny's in luck. That's 80 degrees. What if I check 80 degrees over here? Here's 80. And I'm going to continue this out. That way it connects. So, this angle, I'm not going to write an 80. But these 2 angles match. So we check AA. Are these 2 triangles congruent? No way. So I provided a counterexample showing, look, just because they have 2 angles doesn't mean they're the same triangle, right? Just because we have 2 angles matching doesn't mean they're the same. Try that for 3 angles now to see if you can make a different triangle with all 3 angles being different, or all 3 angles being the same. Try that with 2 angles on one side. What's the minimum amount needed? Also, be careful. 2 angles in a side is different than an angle, a side, and an angle. Order matters here. 2 angles in a side would be this. 2 angles next to each other, then a side. An angle, a side, and an angle would be when you know these 2 angles with a side in between. They're different things to check. This is new, this is different, this is weird. Angles are strange because they don't have length associated with them, so it's kind of hard to visualize it. Try it, though. I'm going to walk around and help you guys, okay? All right, which one are you guys going to try first? Go get protractors back there. Go get your protractors. I'll be back in just a second. Luke, make sure that ends up back there when you're done, okay?
Okay, why is it there?
I believe that Schlaffer put it there, and it's his.
Okay.
I'm so tired.
I could have just borrowed this one. Just put the second one back up there.
Which one's the angle?
Should have been paying attention, Dan.
Thank
Yeah.
you.
The big one is the big line.
The one like this on the inside. Or maybe something like these.
So we're gonna make one big triangle like 60 degrees.
Why? Why?
I don't know. I don't know. I was supposed to make a line. Don't forget the line.
Huh? Wait, what?
So you gotta. We're gonna flip this over and pretend I didn't do anything.
So you do put.
So you have to make a line first.
Wow.
You remember that? I didn't do that.
Well, I did get a picture of her, and she wasn't good enough for you.
And then you line this up with
Did
this
they have that for
line.
everything?
And I'm just gonna put 60 degrees.
Sorry, everybody. My green medicine makes me really thirsty, which in turn makes me drink a lot, which in turn makes me pee a lot.
Nancy, she's not.
Are you guys checking three angles right now? Is that what you're doing?
I'm checking making angles.
Awesome. And remember, order matters. So side and side AA is different than ASA. Does that make sense?
I
So you have to check it
definitely
separately.
triangle.
Awesome. What are you guys checking right now?
Give me what side, side, side,
Because from
We
the
already
second,
checked this out.
no,
Yep.
it's okay. There's like nothing in it.
Yeah, like
From the second one, you start.
Okay, okay,
You
alright.
okay?
Yeah.
Hey, we talked about this.
Okay.
This isn't working, right? It's not. It could be so much better. Here it is.
This is the side you can break down.
Okay, so
For the second
you
one,
have to
you have
make
to
two
start
angles
from
that are the
different
same
sides.
for both triangles, okay? And then you have one
Right?
side. If you're trying to check a side to be the same, what I like to do is instead of measuring with a protractor, is I like to just use the graph paper and say, look, side length 4. Right? So I can check a side and an angle on both sides like this. So what angle do you want me to check here? Let's do 50 again.
You know how to use a protractor.
So this is a 50-degree angle. I'm going to draw another triangle with length 4 and do a 50-degree angle there as well. So there's 50. So I'm going to try angle, side, angle. That's what I'm looking at right now in that order. So I have an angle here, a side there, so my other angle has to be here. Does that make sense? Angle, side, angle in that order. So let's do 40. So I'm going to go to this end right here and do 40 degrees. Now notice because I'm going to the left on my protractor, 40 is here. It's up top. So here's 40 degrees going to the left.
That is
Does that make sense?
yes.
It's 40 here. It shows 140 is the other option because if I was counting from this direction, it would be 140 degree, right? Linear pair theorem. So now if I go here and do 40, you should notice we make the same triangle, don't we? Here and here. The two angles in the side in the middle does lock in the triangle. There's only one way to make a triangle with those two angles in that side length, in that order. Angle, side, angle.
But you can make a different triangle with just angle, right?
So angle, side, angle is enough to get it done. It locks in the triangle, right? Having an angle, a side in between, and then an angle does work. Now, does angle, angle, side work? That would be when you have an angle, and then one of the other sides is locked in. Does that make sense? Angle, side, angle is different than angle, angle, side. So try that one out. So angle, side, angle does work. Just like side, side, side does. Try the rest.
Okay, so angle, angle, angle does work. I've determined
Angle, side, side, yes.
by my two triangles here.
I would caution against using. Oh, also, I would caution against using 90-degree triangles because 90-degree triangles have very special properties.
90s?
Okay, right triangles I would, but in general, yeah, that would be.
I assume Dang, it's easier to get the
Angle, side, side, yep, that works. Yep.
My brain doesn't work this way necessarily.
If you need to use the the measurement side of the protractor for length. For your homework, try the rest of these. Figure out which ones work and try to find shortcuts. The idea being, if we know that triple S works, we don't have to check this because it already has a triple S in it, right? So we're trying to find the minimum number of things to check. Do that for homework.
It goes that fast.